Welcome to today's webinar on AWS WAF for bot control and fraud prevention. My name is Harit Gaddamanagu. I'm a senior solutions architect with AWS Edge Services. I'm joined today by Moon Hussain, who is our principal networking and security specialist. Together, we are here to talk about AWS WAF, AWS Bot Control, AWS Fraud Control, understand how all these features work, how to get started with client-side integration, and talk about best practices at the end. To get started, I invite Moon to establish a baseline overview of AWS WAF.
Thank you, Harith. So let's take a look at the threat landscape. So web applications and APIs face things like, security risks that can cause downtime and also consume excess resources. There are attacks that target the availability of your applications, things like denial of service attacks. There are also attacks that are more common to your applications, like application-based exploits. An example of an application-based exploits would be things like SQL injections that can send malicious code to database servers for the purpose of actually stealing sensitive information. And finally, there are also bots that are designed to manipulate, defraud, and also disrupt your websites or your APIs for that matter. And in this area, Harith will actually cover this piece in greater detail as we go through the presentation. So AWS WAF can help with all of these different attack vectors. But first of all, what is AWS WAF? So on this slide, you see AWS WAF being defined. It's a web application firewall that helps protect web applications from attacks similar to what we saw on that previous slide. That typically target availability of applications, they compromise security, and they also aim to exhaust resources. In AWS WAF does all of this by allowing you to configure rules that allow, block, or monitor web requests based on conditions that you've defined. Now, apart from the detection and remediation actions that are supported on AWS WAF, one key benefit that customers enjoy is the ease of deployment and also the value it brings when you consider the use cases that it unlocks when deploying AWS WAF alongside other key services offered by Amazon. So firstly, from an ease of use standpoint, you can deploy it in a few clicks to protect your applications, whether they run on the cloud or on-prem. There's no need for things like reverse proxy, DNS setup, or things like importing of TLS certificates, or anything that causes operational overhead, which greatly sort of reduces the complexity of this setup. You can enable AWS WAF at the edge through CloudFront, which is our content distribution network. So when you create a web ACL, you can specify one or more CloudFront distributions that you want AWS WAF to inspect. You can put it directly on the top of your ELB at a regional level to protect regional endpoints as well. So if your architecture is serverless, for example, or you have a microservice, you can use WAF to protect applications with API Gateway. You can also use AWS WAF for your GraphQL APIs in AWS AppSync, which also allows more control and visibility into the HTTP traffic for your API that's accepted by your API. AWS WAF also integrates with Amazon Cognito, making it easier to protect Amazon Cognito user pools and hosted UI from common web exploits. So, how does the user govern what AWS WAF inspects? So AWS WAF gives you control over which traffic to allow or block to your applications by defining customizable web security rules. Users can very quickly get started by using managed rules for AWS WAF, and these include pre-configured rules for protection against the more common exploits. So once you have these baseline rules enabled, they could be bespoke environments where you like to perform, different levels of customization. So you can customize an existing rule or create your own rules to filter out specific traffic patterns based on any HTTP parameters Could be based on geolocations, IP reputations, frequency of requests, and so on and so forth. Also in the area of customization, AWS WAF also supports custom header insertions, custom response codes, and labeling for inter-rule communications in the same web ACL. We have customers who also want to leverage third-party rules, so AWS WAF supports third-party managed rules. Lastly, AWS WAF also supports action types, or more commonly known as remediation actions for newly configured WAF rules. Things like allow, block, or count. Now, count is a non-terminating action, meaning that it's a pass-through action. So this is the recommended action type for all newly configured WAF rules and can be thought of as a monitor mode, if you will. Another action is capture, that requires the end user to solve a capture puzzle to prove that a human is actually requesting the request. And another action is a challenge action that runs a silent challenge that requires a client session to verify that it's a browser and not actually a bot. So moving forward, the typical journey when you're deploying AWS WAF is to perform the steps that we just covered relative to the managed rules and the customized rules. There's usually a fair bit of tuning that follows that aims to reduce false positives. And then over time, customers can also delve into more sophisticated detection techniques that you see on this slide. So here, customers can use intelligent threat mitigation features like bot control and account takeover protection. So bot control checks various header fields and request properties against bot signatures. And this is to detect and categorize automated bots such as scrapers, scanners, and crawlers. Account takeover protection, commonly known as ATP, also gives you visibility and control over login attempts from bad actors using compromised credentials. And this obviously helps you protect from fraudulent activity. And Harith will take you through a deep dive of these advanced capabilities later on in this presentation. So now that we've covered the detection capabilities and techniques that AWS WAF supports, let's spend a little time discussing how AWS WAF offers a real-time visibility or near real-time visibility into your traffic and how you can monitor activity using AWS WAF. So AWS WAF offers near real-time visibility that you can use to monitor your AWS WAF with Amazon CloudWatch. So this solution allows you to monitor, store, and access log files from many sources, including logs from other AWS services. You can collect various logs to manage them together. You can also create specific dashboards to efficiently monitor logs on a daily basis. Other monitoring tools supported by AWS WAF are AWS CloudTrail, that provides a record of actions taken by a user, a role, or an AWS service in AWS WAF. And then you can also use it with the support that we provide for AWS config services. So from an auditing, compliance, and regulatory perspective, some customers rely on logging tools. So this next slide will get into logging. And for this purpose, AWS WAF supports full logging, where you can log each inspected web request data for security, automation, analytics, or different auditing purposes. Logs can be directly sent to a CloudWatch log group or S3 buckets, or piped through Amazon Kinesis data firehose, which allows you to specify all of these options for storage. So we've discussed how data can be monitored and logged, but in order to make data and alerts more actionable, let's look at ways to layer on analytics. And for analytics, you can build dashboards and analytics on top of these logs by integrating with AWS services like Amazon Athena or Amazon CloudWatch Insights. There's also an ability to directly click on CloudWatch Log Insights to run queries. And this is done natively within the WAF console, which is really cool. You can also pipe your logs over Amazon Kinesis data firehose, or use Kibana over S3 or Amazon OpenSearch for analysis and visualization. So I hope this gave you a quick overview on AWS WAF fundamentals. So what I'll do now is turn it over to Harith to cover bots, account takeover, and best practices. Harith?
Thank you, Moon. Let's talk about AWS WAF bot control. But before that, what is a bot? Typically, bots perform tasks that are simple and repetitive at a faster pace than humans, right? There are different types of bots, and they are broadly categorized into two types: good bots and bad bots. Let's talk about good bots first. So, these bots are your search engine crawlers, website health checking monitors, your vulnerability scanners to understand your application. And these good bots can be identified by traits like they tell us who they are, they rate limit themselves, they do not overwhelm your application with requests, they adhere to standards set by robots.txt, they cache data that they collect on your website, and they do not cause any intentional harm to your websites. On the other side, we have bad bots. The common traits of bad bots are like they do not explain who they are. They're not transparent. They test your application to the limits. They abuse, right, and they do not respect robots.txt. They do not adhere to caching. On top of it, like these bad bots work together for various illegal activities like distributed denial of service attacks. They come together for common spams. They are part of SEO spams and also fraud. Let's understand the impact of these bad bots. Broadly speaking, these bad bots cause infrastructure attacks and application attacks, or infrastructure impact or application impact. These infrastructure attacks are targeted towards the underlying hardware or the host, and bad bots cause increase in your infrastructure cost. They aim to bring your application down. They result in loss in revenue that is generated on your site. On the other side, the application attacks are targeted towards the application itself. They are more about how do we steal the data that is stored on your website. Attackers or these bad bots using compromised credentials to get to the website, leaving spam or fake reviews. The whole agenda is all about how these bots can affect your website so that you lose your customer trust. There are a lot of financial repercussions and negative PR associated with these bot attacks. So how can AWS WAF help here? The core functionality is provided by Bot Control Managed Rule Group. Bot Control Managed Rule Group provides a basic common protection level called common bots and an advanced protection level called targeted bots. These are available to all AWS customers as managed rule groups. A bot control managed rule group, provides common protection level that adds labels to self-identifying bots. With these are your good bots. These are verifies generally desirable bots and detects all these bots with high confidence bot signature. They also give you ability to monitor and control common categories of bot traffic. Common bots use signature based detection or take a look at the IP addresses, the request headers that are being sent, and also perform some of the things like reverse DNS lookup to understand if the requester is who they claim to be who they are. On the other side, for advanced use cases, we offer targeted bot control. This targeted protection level adds detection for advanced bots that do not wish to self identify. Targeted protections use advanced detection techniques such as browser interrogation, fingerprinting, and behavior heuristics to identify bad bot traffic and then applies mitigation controls such as rate limiting, capture, or challenge rule actions. We'll talk about these rule actions in the next slides. We also use advanced techniques like ML based behavior analysis, behavior based detection, and to understand what the intention is and take the respective mitigation as necessary. Let's take a look at common bot control and how it looks like on the console. As mentioned, common bot control is it's intended to detect self-identifying bots such as your web scraping frameworks, your search engines, and your automated browsers. Bot control protections at this level identify these using traditional bot detection techniques such as static request data analysis. They also generate labels as seen here on the screen and block the ones that they cannot verify. It is ideal from protecting your application from generic bot problems like scanners and crawlers. Like I mentioned, this is exposed on the to our AWS customers, like an Amazon managed rule set. You can select individual rule actions as desired, and you can customize it as per your application requirements. Moving on, the targeted bot control includes common level protections that we seen previously and also adds additional detections for advanced bots. Targeted protections use advanced detection techniques such as browser interrogation, fingerprinting, behavior heuristics, machine learning, baselining, and all the other additional things to identify these kind of bad bot traffic. These protections, these protections target these bots using a combination of rate limiting and captcha and background browser challenges. Typically, on the console, their names begin with a TGT prefix. Targeted bot control allows users to track, how many requests are coming in per session per IP. We can automatically detect attack vectors before they even make it to your application. We behind the scenes we are using cryptographic tokens by a process known as challenge interstitial exposed as the challenge rule action on the console. This is how on the console we expose this feature. There are two types of actions available inside the targeted groups, targeted bot control groups. These are the challenge and capture. Let's talk about them in the next slide. But before that, I just want to mention that targeted bot control supports client-side embedding, client-side JavaScript embedding, or mobile API, mobile SDK embedding that can work with your application and generate tokens. These cryptographic tokens are essential in understanding if a request is being made by a good bot or a bad bot or an legit user. Let's talk about the challenge action in this slide. Targeted bots challenge rule action. A challenge action runs a silent challenge that requires the client session to verify that it's a browser and not a bot. This verification runs in the background without involving the end user. This is a good option for verifying clients that that you suspect of being invalid without negatively impacting end user experience. Let's see how a challenge rule action works. When the browser makes a request to an application behind AWS WAF with a challenge action configured, or in this case for targeted bots, if a request comes in without a token or a WAF, then a challenge action is called. Browser then serves a JavaScript challenge to your end user, and so that this end user executes this JavaScript and then calls the token server, and the token server generates a unique challenge script. Browser then executes the script, performs interrogation, and solves a challenge. On successful challenge completion, a cryptographic token is provided to the browser by this token server. Browser now stores this token as part of its cookie configuration. Browser pages refresh to use this token, and all future requests that contain the token will contain this token, and the content is now served. And your AWS WAF, which is governing this site's security, would understand that, hey, this challenge is solved, and this is a legit browser, not an actual bot with malicious intent. Now that we've seen the challenge rule action, let's take a look on how the CAPTCHA action works. The CAPTCHA stands for completely automated public Turing test to tell computers and humans apart. It's self-explanatory. CAPTCHA puzzles are designed to verify that a human is sending a request and prevent activities like web scraping, credential stuffing, and spam. AWS WAF allows you to configure an adjustable immunity time for CAPTCHA on saying that how long that a token that is generated by CAPTCHA is valid for. You can configure it as required by your application. There are different CAPTCHA challenges available. CAPTCHA, we also include an audio version, and these CAPTCHA challenges are designed to meet WCAG accessibility requirements. These are Web Content Accessibility Guidelines. Keep in mind, like the CAPTCHA are also available as a rule action for other WAF rules. These are all the CAPTCHA puzzles available for us today. Now that we looked at several bot control options, let's take a look at AWS fraud control landscape. AWS offers several fraud detection solutions like AWS WAF and AWS Fraud Detector. AWS WAF provides account takeover prevention functionality. We'll talk about this in the next slide. And AWS Fraud Detector service. AWS Fraud Detector is a fully managed fraud detection service that automates the detection of potentially fraudulent activities online. These activities include unauthorized transactions, creation of fake accounts, and things like that. Amazon Fraud Detector works by using machine learning to analyze your data. It does this in a way that builds off the seasoned expertise that we built here at Amazon for over 20 years. You can use Amazon Fraud Detector service to detect credit card fraud, fake account creation, and other fraudulent activities. Today, in context of AWS WAF, let's discuss account takeover feature to prevent fraud. But before that, let us discuss account takeover. What is account takeover attacks, or what are these attacks? Account takeover it's an illegal activity in which an attacker gains unauthorized access to a person's account. An interesting stat from a recent Forbes report tells us that almost 30% of these attacks, uh, almost 30% of the attacks that happen on e-commerce sites are account takeover. These attacks pose a serious threat to your business. And there is a rising trend on these type of attacks. In order to pull these types of attacks, attackers usually sort to uh, methods like credential stuffing, where where they use stolen credentials, or they keep guessing victims' password through a series of attempts. When the attacker gains access, they might steal money, information, or services from the victim. Another way to achieve this is through brute force password attacks. Here the attacker might pose as the victim to gain access to other accounts that victim owns, or to gain access to other accounts of peoples or organizations. Additionally, they might attempt to change users' passwords in order to block the victim from their own account. It's essentially um, the whole account takeover attacks is focusing on making the account do things that the regular user would not expect it to do. So, how AWS WAF can help here? AWS WAF provides account takeover prevention manage rule group. The ATP manage rule group labels and manages requests that might be part of malicious takeover attempts. This rule group does this by inspecting login attempts that clients send to your application's login endpoint. Keep in mind, we can look at login attempts and also responses. ATP gives you visibility and control over anomalous login attempts and login attempts that use stolen credentials to prevent account takeovers that might lead to a fraudulent activity. ATP has ability to check email and password combination against its stolen credential database. And this database is regularly updated as new leaked credentials are found on the dark web. Further, ATP can aggregate data by IP address and client session to detect and block clients that send too many requests of a suspicious nature. Talking about response inspection, um, as of today, for CloudFront distributions, in addition to inspecting these incoming requests, ATP rule group can inspect your application responses for login attempts. We do this to track success and failure rates. Using this information, ATP can temporarily block client sessions or IP addresses that have too many login failures. Keep in mind, AWS WAF performs response inspection asynchronously. So this way, we do not increase any latency to your web traffic. Again, on the console, this feature is offered as a WAF manage rule group. You can turn this on without any, with some additional configuration, but by a couple of clicks. So as mentioned previously, ATP can also integrate with SDK. ATP can detect brute force attempts that try to log into your website. We have ability to check response codes and also other signals. To configure this on your console, additional configuration needs to be provided. We would need the following information that you see on the screen. We would need to know the login path or your sign-in page or URI on where we can run these detections. We would like to understand the payload type. Is it a JSON or a form encoded body? We would want to know what your username fields and password fields are so that we can locate this within the body and understand, look for stolen credentials or other user behavior that can indicate ATP attempts. That being said, let's look at client-side integration piece. With AWS, you can also couple client-side verifications with your server-side Web ACL protections. You can do it with client-side SDKs. These SDKs verify client application with silent challenges and provide AWS token acquisition and management functionalities. I would say this is similar to the functionality provided by the AWS WAF challenge rule action that we discussed previously. The SDKs allow you to serve a silent challenge when a user makes a login attempt, allowing you to differentiate attempts made by a legitimate user versus bot. These SDKs collect additional telemetry, which helps with generating unique identifier for each request, which is more granular. Keep in mind that these SDKs integrate with advanced managed rule groups like targeted bot control and ATP that we discussed today. Though it is highly recommended to enable client-side SDK, it is still optional. Um, there are two types. I mean, there is a JavaScript SDK that is generally available. You can use it for your browsers and other devices that you can execute JavaScript on. And for your Android and iOS mobile apps, AWS WAF also offers custom SDKs for Android versions 23 and later, and iOS versions 13 and later. The client-side integration enables ATP functionality, targeted bots functionality to work as they are intended. It is easy to configure and implement them. Uh, let's take an example to understand how to implement these SDKs. Let's pick an example on how to integrate ATP JavaScript SDK to make that account takeover prevention attempts work. After adding the account takeover prevention managed rule group to your web ACL, navigate to the detail page, click on edit. So once you click on edit, here you would see a challenge URL for your web ACL. You would copy it and paste this challenge URL into your sign-in page. That's it. And from there on, whatever your users, whoever will reach to the sign-in page, would generate client-side tokens that ATP rule group can use to understand account takeover attempts. Of course, it is not this simple for complex sites, but I want to just show you how easy it is to implement. That being said, let's talk about some of the best practices that you can use with intelligent threat mitigation feature sets that we've been discussing today. Some of the best practices for threat intelligence mitigation is implementing the JavaScript and mobile application integration SDKs. Implement application integration to enable the full set of ATP or bot control functionality. Uh, you know, you should do it if you want to use it. These rule sets to the most effective way. Limit the rules that you can send to ATP and bot control rule groups. You can do this using scope down statement. There is a cost benefit associated with it. And it also falls onto our best practices configuration wise. We also recommend to reject requests with arbitrary host specifications. So you configure your protected resources to require that the host headers in web request match the targeted resource. Using Shield Advanced Auto Mitigation Layer 7 DDoS mitigation. So if you're trying to solve layer 7 DDoS problems, you can integrate with Shield Advanced Automatic Layer DDoS mitigation rather than relying on ATP or even though these targeted bot control, even though these rule sets have ability to rate limit. But if you're aiming to mitigate large-scale DDoS attacks, using Shield Advanced is a better way. Testing and tuning rules is important before you deploy. So before you implement any changes to your web ACL, follow some of the best practices like putting rules in count mode, understanding what's happening, collecting metrics and logs. And once you're finally confident, you can toggle them into the rule action that you please. Finally, fine-tuning your token immunity times. So this is done to adjust the web ACL's token handling for best user experience. And also, this is a cost saving opportunity. Another aspect that I want to discuss today is managing false positives. We have carefully selected the rules in the AWS WAF Bot Control Manage Rule Group to minimize false positives. We test these rules against global traffic and monitor their impact on test web ACLs. However, it is still possible to get false positives due to changes in traffic patterns. Here are some options and some of the things that you can keep in mind to manage false positives on AWS WAF or bot control. These are mostly how-tos. Number one is allow listing trusted request. So if you have a list of trusted partners or trusted mobile apps or certain user agents that you want to allow, you could create a rule with a with a lower priority and put it on top of these advanced rule sets so that you allow them. Another way to do it is by generating labels. You could generate labels for all these requests and by toggling the rule action to count and later use these labels to selectively exclude some of the rules. There is more documentation available and blogs available on this. So I would consider that for further reading. Scope down statements. So instead of applying some of these advanced rule sets for the entire website, you could scope it down to certain aspects, to even certain pages or to certain geolocations and things like that. And the number 4 and number 5 points that you see here are just like some of the things that you should keep in mind. Like there can be changes in your existing request flow, like some users coming in through different paths that can affect the bot control or ATP functionality. Just keep in mind, like if somebody introduced a CDN workflow in between, that can change the way things are perceived. Another way where false positives are introduced is emerging user behavior changes. Like for instance, this could be a change in historic traffic patterns, new browser agents, a new set of users that can affect the machine learning functionality with bots. So these are with our newer capabilities, we are constantly learning what is good and bad for you. So those things can affect. Uh, Another important point that I want to cover today is configuring these advanced rule sets for cost optimization. I have a lot of customers who asked me this. Like simply put, for cost optimization, we request all customers to limit the request that you send to the ATP and bot control rule groups. So there is an additional premium fee that gets associated with this rule groups. Uh, if you are misconfiguring or if you're not configuring for cost optimization, there is a fair chance that customers there is a risk of incurring high charges. To avoid that, let's take a look at some of the options that we have today. Exclude request from inspection by adding rules before the rule group. For rules that you cannot use in a scope down statement or for more complex situations such as labeling followed by label matching, you might need to add rules that run before these rule groups. So you could use scope down statements or you could add rules on top of it. So to stack and to limit the number of requests that are being processed by these advanced rule groups. This is the same thing, like run rule groups after the less expensive rules. So if you have less expensive rules, run them first. If you have other standard WAF rules that block requests for some reason, put them on top of these paid rule groups. If you are using both ATP and bot control rule groups, run the bot control rule group first. It's the less expensive rule group. It's less expensive, so use it first. Adding a rate-based rule to prevent abuse, inspection fee. Like for instance, if you want to stay certain limits, and if you don't want to pay more than a certain range, you could rate limit on the scope down statement and prevent excess requests being processed by these premium rule groups. Further, to reduce operating cost and improve your end user experience, tune your token management immunity time to the longest, so that your security requirements allow. So these keeps so if you do that right, this keeps the use of captcha, puzzles, and silent challenges to minimum, so they don't keep on running. That's one way to save money. Another way to do so is using IP reputation list like Amazon IP reputation list or third-party IP reputation list that can block commonly observed bots. We recommend Amazon IP reputation list. We have a threat intelligence team that curates this a list of bad actors, and we update this constantly as well. So this can help you further limiting a request to our premium rule groups. There are more best practices described in our documentation. Feel free to take a look at them. But these are some of the things that I can think of today. Finally, let's take a look at an example web ACL configuration. This helps us understand how all these tools come together. So here on my screen, I have a web ACL. Keep in mind that this is not web ACL for all use cases. This is something that I have here to show you how bot control and ATP can be configured together. So customers generally add reusable rules first. These are your allow list and block list. Allow list typically have your trusted IPs, and block list have your risky user agents or some combination of bad actors that you don't want. After this, we have customers who use AMRs, or like Amazon Managed Rules, like the Amazon IP reputation list. You can set it to count, or you can select it to block, as you wish. After that, I have some common rule sets which offers protection from our top 10 OWASP. Consider using this kind of rule group for any AWS WAF use case. Then we have AWS WAF Bot Control, which is selectively enabled on some parts of my website for cost optimization. From here, I start some customization. I'm using WAF labels to take desired rule action when a rule matches on the web request. If a rule has label defined in it, AWS WAF adds a label to that request. Rules that are evaluated after matching this rule in the same web ACL have access to this label, so they can further match against them. That is what I'm doing here. As previous bot control, let's say in this case, the previous bot control is set to count, and it is generating labels on verified bots. And I'm using this configuration below to allow only good bots. So I'm using that label. You can do something similar by generating WAF labels and blocking them, or doing something else as well. Further, I am using a rate limit rule and selecting captcha. This is I'm using a higher threshold to prevent abuse on my ATP AMR, like ATP managed rule, just to prevent abuse. After that, I am using ATP account takeover prevention rule set that is available to track multiple account takeover activities. This is similar to what we learned previously. After that, I'm using a stolen credential rule set. So I'm generating labels of ATP rule set here, right? And then I'm creating another rule that says like redirect, users who come in with label, or redirect requests that come in with a label that says, that they have used a stolen password. This is just an example here. It's not like, I mean, it's for a specific use case. Lastly, I'm using a blanket rate-based tool. Um, and this is to protect the availability of the application. Now that we have seen how all these rules come together to secure your endpoint from a variety of attacks, I call on Moon to conclude this session.
Thank you, Harith. So there you have it, folks. Hopefully this gave you a good understanding on the fundamentals of AWS WAF, an insight into special topics that Harith discussed relative to account takeover, bots, and also best practices for tuning AWS WAF. Next steps, from a call to action standpoint, we invite you to visit our product page to get more examples, insights into blogs, documentation, and then also a getting started guide that will give you sort of the best tips for proceeding with a proof of concept for AWS WAF. I'd like to thank you for your attention and thank you for watching.